Okay, we're going to go ahead and finish up with this example. We left off looking at the x-intercept, and so what we're going to do is when we're looking for the x-intercept, truly the y value would be 0, because it's where it crosses the y-axis. I'm sorry, it's where it crosses the x-axis, but where y is 0. Alright. So what we're going to do is the entire thing would be set equal to 0. Now, I'm going to tell you right now, we're going to only use the numerator where it's x plus 1 from our simplified function, and this is y, and I'm going to show it once, but in the future, if you're looking for the x-intercept with rational functions, you are only looking using the numerator, because when I have the entire simplified function set equal to 0, our very first step on all of them is to multiply by the denominator, which is x plus 3. Now, whenever I multiply 0 by anything, it becomes 0. So that's gone. So we're left with 0 equals x plus 1. All right. So when we're going to go next, we're going to go ahead and subtract 1. So x would just equal -1. My pen is acting up. I apologize. So if it's an x-intercept, we need an ordered pair. So this is going to be -1 as our x value. Now our y value, we need to substitute back into our simplified formula. So I'm going to substitute that back in using a different color. And that's going to end up being -1 plus 1 divided by -1 plus 3. And I just went back to the regular, this one right here. Okay. In the numerator, that just becomes 0. I'm sorry, we don't have to do that step because we already know that y is 0. Okay. So that would be our point for the x-intersection section. Now, to find the y-intersection, what we're going to do is x equals 0. So we're going to use that standard, we're going to use that formula here. We have x plus 1 divided by x plus 3. And we're substituting 0 in for x. So that's going to be 0 plus 1 divided by 0 plus 3. Okay, this would simplify down to just y equals 1/3. And our ordered pair would be 0, 1/3. Okay, now when we're talking about domain and range, it's best to go ahead and graph it. So when we're looking at this, we are going to start off with our graph. We can test a few points if we'd like. And so if I already know my horizontal asymptote is here, I already know the x-intercept is -1, 0. That's where it's going to cross the x-axis. The y-intercept is going to be x is 0 and y is 1/3. My horizontal at 1/3. That's not right. Hold on. Aye. So we have 1, and then we need 1/3 would be the y-intercept. So that's going to be really close to here, and I have changed colors. Great. And as we do need to talk about that vertical asymptote, which I'm surprised. Oh yeah, it's right here. So x equals -3. So that vertical asymptote is going to end up being positive -1, 2, 3. So this is going to end up having a vertical asymptote at x equals -3, horizontal asymptote at y equals 1. Okay, so as we're approaching, change to purple. We're going to start here and we're going to go all the way down. Okay. Now for our other graph, it's going to be reflected. It's going to be up here. And this is just a sketch. Now when we're talking about domain are all x values. It would be all real numbers, except where x is not 3. -3, sorry. And then for our range, which are y values, if we were doing let's go ahead and it would just be all real numbers except when y is 1. Alright, let's go ahead and take a look at example 3. So with example 3, we do have to find a few different things. It's asking for asymptotes, holes, x-intercepts, y-intercepts, domain, and range. Okay, so looking at the first step up here is we're going to go ahead and factor the function. So in the numerator there's nothing to factor out, so I'm just going to bring that over. In the denominator, I notice that I can factor that out using the AC method. Okay, what factors of -4 add up to give me 3? And that's going to be +4, -1. Adding those together would end up giving me a +3. Now I notice in the numerator and in the denominator we have a removable discontinuity, and that's at x minus 1. So that means that at x, when x is 1, we're going to end up having a hole right there. Oh, sorry. I knew I was going to do this. I forgot to put the hole up here. So at 1 and 1/2, which is right here, we're going to have an open circle. So with your pen or pencil, this is open, not solid at all. So that means we cannot include those values. And so that's going to change our domain. Our domain is going to end up also including that it can't be -3 or -1. Our range is going to be 1 and +1/2. And that's based off of our values here. Okay, see, I knew I was going to forget that. I'm so sorry. And now I'm crazy talking to a computer screen as if you can understand me. Well, I know you can understand me, but it's the fact that I'm having a conversation back and forth. Last week of digital teaching, guys. Alright, back to this. I wonder how many of you guys will actually hear this. But anyway, here's my simplified equation of 1 divided by x plus 4. And my hole, we already found the x value is going to be 1, so we're going to substitute it back into our simplified function to find what that y value is. So y would equal 1 divided by 1 plus 4, which would just be 1/5. Alright. Now our asymptotes are our denominator, so we would end up having a vertical asymptote. And our vertical asymptote is going to be at x equals -4. Okay, and then our horizontal asymptote is just going to end up being at y equals 0. Whoa. Did not like that. Y equals 0. And that's because we have more x variables in the denominator, just as our parent function. So it would always end up being whenever the x value is higher in the denominator, it's always going to be your constant that's on the outside, which in this case is 0. Oh, alright, x-axis. I'm sorry, x-intercept. So x-intercept, we know that y is going to equal 0, and we're going to take a look at the numerator. So when we're looking at the x-intercept on this one, it's going to end up being 0 equals 1 divided by x plus 4. So in this case, we're not going to have an x-intercept because our horizontal asymptote is on y equals 0, and that doesn't allow it. So you would just say none. Because if I multiply both sides by x plus 4, that would cancel out, and I would end up with 0 equals 1, which is no solution. Alright, y-intercept would be x equals 0. So what I'm going to do next is I'm going to go ahead and plug in my simplified function. I'm going to end up having 1 divided by 0 plus 4, which is just going to end up giving me 1/4 for my y value. So that's going to be 0, 1/4. And then the domain, we do have a hole, and we have a vertical asymptote. So it would be all real numbers, except x cannot equal -4 and 1. All real numbers, except y cannot equal 0 and 1/5. Alright, so that concludes that problem. It doesn't ask us to graph, which is great. Okay, we have one more example, and this is a little different. Alright, so with this example... no, go away. Alright, so with this example, we're going to go ahead and start off with filling in the table just to kind of see what's going on with this graph. Okay, so if I have -5 in the denominator, that would just be 1 divided by negative 5 squared. That negative is on the inside, so it's going to be negative 5 squared, which is positive 25. This would be positive 4. 1 divided by 1, which is just positive 1. And when we have a fraction in the denominator, this is what's truly happening. So you're going to square that, so that would end up being 1 divided by 1/4. We have a fraction in the denominator, so we are dividing by a fraction, which in the long run you would actually multiply by the reciprocal, which the reciprocal of 1/4 is just 4. So in the end, this is just 4. Okay, and then 1 divided by 0 squared is going to be our undefined, so I know right now we have a vertical asymptote right here. Okay, then we're going to end up with 1/4 in the denominator again, multiplied by the 4, so we would end up with 4 again. And then 1 divided by 1 squared, 1 divided by 2 squared, which would be 1/4. And then 1 divided by 25. So we have something going on that's kind of interesting, and I noticed that in the denominator we do have a quadratic equation, but it's a rational equation before it's quadratic. Okay. So when I graph these points, I'm first going to go ahead and change the color, and I'm going to go ahead and graph the vertical asymptote first. So our vertical asymptote starts at x equals 0, because we already identified that here. Okay, we have more degrees in the denominator, so we're going to end up having our horizontal asymptote equals 0. And this would be our vertical asymptote. X equals 0. I'm missing y. Okay. Wonder if you can see that okay. There we go. Alright. So in this one we also don't have any holes, so it's just vertical and horizontal discontinuities. And we're going to go ahead and plot these points. I'm going to pause it here, plot the points, and come back. Alright, now I told you this one was going to be a little special, so I plotted the points already, and I'm going to go ahead and trace those lines now. And as I continue on, if I look at only one piece, it does look like a rational function, but in this case we're not reflecting and ending over, I don't know what I was doing there, in this quadrant. We're actually going, because of this squared, kind of looks like a crazy, because you know how quadratics do this, it's almost like a, if you split the quadratic in half and invert both sides, it's gone crazy. So anyway, this would be our rational function. If you have any questions, please email me. I'm here to help you. I hope you have a wonderful day. Bye.